In this video, we're going to learn how to use trigonometry and related rates, precisely implicit differentiation. So a spectator and an airshow is trying to follow the flight of the jet. The jet follows a straight path in front of the observer at 540 miles per hour. At its closest approach, the jet passes 600 feet in front of the person. Find the maximum rate of change of the angle between the spectator's line of sight and the line perpendicular to the flight path as the jet flies by. Okay. So first we're going to draw a picture, and I'm going to draw the plane's path from left to right. The plane's flying, and I'm going to label its point at any time here. It's a variable point, obviously, but I'm just going to label it the P, the plane's location at a certain time. And I'm going to label the observer at a ground level being, well, so let's label the intersection point. Like here. I'm going to draw the observer here on the ground level, and I'm going to label this O, and the intersection point of the flight path and the line perpendicular to the flight path, the intersection, I'm going to label it as I. Okay, and also we're going to create connect the 2 points O and P and draw a spectator's line of sight. Okay, so that will be, notice that this is, since we're talking about perpendicular, this is a right triangle with hypotenuse OP. So the spectator's line of sight is the hypotenuse OP. So let's see what we're given. We're given 500 miles per hour speed of the plane, and the plane travels along the horizontal axis. So its distance from the intersection point as it moves from left to right is increasing, okay, with respect to time. So we can say that dx dt is equal to 540 miles per hour. But notice that we can't deal with miles per hour because here we're given feet. So we have to convert feet per second, okay, just for convenience. So 540 miles per hour multiplied by 1 hour, 3600 seconds multiplied, so the hours go away. Now we need to get rid of the miles and put feet instead. So it's going to be 500 to 80 feet divided by 1 mile. And the miles go away. So as a result, this would give us, let's see what the calculator gives us. 40 divided by 3600 times 5 to 80. That gives us 792. 792 feet per second. Okay, so that's the rate of the plane. So now realize that we have to find the maximum rate of change of the angle. So the angle between the spectator's line of sight and the line perpendicular to the flight path is going to be the line between OP and OI, right? So angle theta. And realize that it says at its closest approach, the jet passes 600 feet in front of the person. And the closest approach will be when the plane is where the eye is, the point I. So when the plane is here, right above the observer, will be the closest distance of it from the observer. So it's 600 feet, this line segment OI. So now you might say, so what are we looking for? The maximum rate of change of the angle with respect to time, right? So that means we need to find d theta divided by the dt. That's what we need to find. So you might say, but how do we derive it? How do we even find that? Well, we're going to use trigonometry. Realize that the IP can be related to OI by the use of tangent, okay? So tangent of theta, and we're going to label IP as x, okay, because that's a horizontal distance of the plane's location at a certain time from the intersection I, right? So x divided by 600, right? The opposite divided by the adjacent. side of the angle theta. So now we're going to differentiate both sides using implicit differentiation techniques. So first we're going to differentiate the tangent, and we're going to get secant squared theta multiplied by differentiating the theta itself, so d theta dt. Now the right side, x will go away, so 1 over 600, the constant stays there, and then multiplied by the differentiation of the x itself, so dx divided by the dt. And notice that dx dt, we already know that's 792 feet per second. So we need to solve for this guy, right? d theta dt. So d theta dt is equal to 1 over 600 times dx dt times 1 over secant squared theta. And that is equal to 792 over 600 times cosine squared theta, right? Because 1 over secant squared theta is simply cosine squared theta. So what does that give us? Let's see. 600. 1.32 cosine squared theta. Okay. So notice that in order for this to be maximum, right, because we need to maximize d theta dt, the rate of change. In order for this to be maximum, the cosine squared theta must be equal to 1. So cosine squared theta is equal to 1 when theta is equal to 0, right? And that makes sense because as the plane passes by, you will notice even by your unaided eye that it will pass the fastest. The angle measure theta will be changing the fastest when the plane is right above you, where it's at the point I at that instant in time. Okay, so the max d theta dt, d theta dt is equal to 1.32 times 1, which gives you 1.32. Now let's be careful about the units. The units must be radians per second, okay? And not degrees. Why? Because let's think about why it's radians. You see, it's right above you, only 6 feet above you, right? The plane is flying 6 feet above. Okay, there's a vertical distance of 600 feet when it's right above you, and it will keep being like that from the ground level. But as we can see, the plane's speed is 792 feet per second. Okay, so that means in 1 second it will cover more distance than the distance between you and the plane when it's right above you. So if 1.32 degrees per second were there, it would not make sense, right? It's just too little. It's just too little, right? The plane speed is so great that it has to be radians per second, because radians per second, if you were to convert this to degrees, you would see that it would be 1.32. Well, let's see what it would give in degrees. 1.32 times 180 divided by the pi to convert to degrees, it would give you 75.6 degrees, and that makes more sense, right? Because once again, 1.32 degrees per second is just really small. It's like the plane is not even having much speed there, right? So yeah, so it must be radians per second, and that's the maximum rate of change of the angle theta. So hope you enjoyed this tutorial. Please subscribe, and I'll see you in my next video.